Hello ladies and gentlemen, boys and girls, my name is xOctoManx and this is a tutorial and request by some subscriber of course about how to create board games or actually the movement on board games like Ludo, Monopoly, wherever you're going to use dice and where you have like fields where on which you're gonna have to walk onto. So what I will go over is I'm gonna cover the basics of that, or basically how I would do it, and there are probably 100 different possibilities for doing so. So let's get into it. First off, I need to have a playfield, and for doing so, we're gonna create some, let's say, nodes or fields, just flat boxes if you like to. So I go here and create just a 3D cube. It's going to be zeroed out. And what I can do is I can, just shrink this one down a bit so it's looking like a flat field. So what's the problem actually is you want to have a field which is going to go from, or a player, character, whatever, stone from this field to the next field. So I'm gonna duplicate this and snap this over here so you can see stuff better. So what we now have is those two cubes, and we need later on a player which is going to be able to move around on this one, like on the complete play field. So what I would do is I would actually create some kind of node-based system. Well, basically nothing else than a path the player can walk on or go by from one point to the other. In this case, these points are going to be the transforms or vectors of these particular objects. What I would do is at first I'm gonna create an empty game object. You can zero this one out as well over here. And this is going to be my route. I'm gonna name it route, so you can name it whatever you like, of course. And these cubes over here, I'm gonna rename them to be, let's say, nodes. You can also name them playfield, whatever. What I want to do is I want to take these two nodes in the correct order and make sure that I'm childing this one to the route. Pretty simple, right? So what we now can do is we can duplicate those nodes inside route without any problems, of course, and make sure that we add them to some kind of a list or an array. Basically, doesn't really matter. We're gonna do both basically, so to simplify the process. Also, I want to have some visualization where I'm gonna actually draw a line from the center of this point to the center of this point, like between those two nodes, so I see which node is connected to which node based on this route object over here. So once again, this is going to be the parent object. The other two are going to stay over here. What I want to do is I create a new C# script, of course, which is going to do the calculation for me. And I'm going to name this route. So this route object or this route script, of course, is going to go onto the route over here, onto our empty game object, which is once again just a placeholder for this. Let's open this one up in Mono Developer Visual Studio if you like, or whichever you like, and please. I still use Mono Develop over here because I like that way better or way more than that. I'm gonna zoom in so you can see stuff better. First off, I want to get rid of start and update since I at the moment don't need that for the route itself. So what we now want to do is we want to calculate the route. And what we want to do is we want to take all the child nodes or the child object of the route object and make sure that these are going to be part of that particular, let's say, list or array. So what I can do is, and I have a tutorial about this already, so check this out or just watch this, basically doesn't really matter. I'm gonna create an array of transforms of all the child objects we're gonna have over here. And child objects. You can name this whatever you like. You can do typos if you like to as well, as I do. Well, and what I also want to have is a list, which is going to be a public list, so I can see what's going on with that list, and I can access this particular list later on from the player stone, so I can request basically positions on this particular route. You can also do an accessor, like creating a function which is talking to or requesting the correct position of this particular stone. So I'm gonna make it public so I have an easy access later on. Basically, it doesn't really matter for this particular part. And this list is going to be of type transform, of course, as well. So we don't have any problems by, sending data back and forth later on between the array and the transform list. And I can name this, for example, child whatever node list or child object list. Basically, it doesn't really matter. And I initialized this already to be a new list of type transform, open close parentheses, and close the line with a semicolon, as you usually do with all lists you are going to create. Next one, I want to visualize now the path, or like all the distances, or but let's say the connections between one field and the next field. In this particular case, I'm gonna use the function called onDrawGizmos. You probably have seen this already. OnDrawGizmos is just for visualizing purposes, but also can automate things directly in the inspector, unnecessary or not needed in the start later on. So what you want to have is you want to draw all that gizmos directly inside onDrawGizmos. Make sure you type this one 100% correct, otherwise it doesn't make sense at all. So every node or every line I want to draw, I want to give it a color. So I can say gizmos.color is going to be equal color.green. So I can see that better, and you probably do too. Next one is I want to fill in the nodes. I'm gonna create an extra function for that, which I call, or just, yeah, which I name fill node or fill nodes. And in onDrawGizmos, I want to make sure that I fill these nodes over here. Like I just call this function over here to simplify my process later on, because onDrawGizmos is not going to be inside the build whenever you're creating a game. You need to make sure that fill nodes it's getting called from the start function. So, and that's how you basically protect this one later on from doing any fancy stuff like that. What we want to do is in fill nodes, at first, we want to clear the list of child node. So we say child node list, this one, dot clear. So it's empty completely whenever we call this function. Next one is we want to get all child components and add them to the child node list. There are tons of possibilities over here. For now, I'm gonna catch them in the child objects. So I say child objects, once again, is going to be this transform array. You don't have to do this, but you can. I'm gonna catch all of these into this array, and then I say get components with an S in children, like this. And what I want to get is all transform type components or inside the children. Whenever we are done with that, we can loop through with a for or for each loop through all the child objects we have collected. So we can say for each type of transform, then we give it a name, child or whatever, in. Now we're gonna talk to our child objects array. So in our child objects array, we want to actually loop through that. What we want to check at first is if this child we are currently looping through is not the parent object, so we can actually get rid of it, or basically we don't have that inside because we don't need it. So in this case, we can say if child is not equal to basically this particular transform. You can also, to not confuse yourself, type in this dot transform. Doesn't really matter, transform or this dot transform, both do work. So once again, on this route object where we are going to be on, we don't want to have this the own transform actually on this particular one. So we don't add the empty one, which does not actually represent a field, if you can say that like this. So, and what we want to do is, of course, we want to add all this currently looped through ones to our child node list. So we say child node list dot add, and what do we want to add? Of course, we want to add the child we are currently looping through. Once again, it's going to be this one over here. Okay, cool. So now let's finish up the onDrawGizmos function so I can show you what's going on with that. So actually, we can loop through, or we now loop through all the filled nodes and paint some lines from one node to the next node. In this case, we can make a use of a for loop in here. So if you type in for and double tab, like on the tabulator button on the keyboard, you're gonna get the for loop created already instantly. So I go to the second one, which is saying max, and what I want to go into, of course, loop through is the child node list dot count. So not clear, but count. So the amount of currently added nodes inside that list, we want to loop through them until we are reaching the end, basically, and increment I meanwhile doing so, as usual. So next one is we now want to create a current vector position where we are starting to draw our line from. In this case, we just create a new vector. We can call it maybe current POS, doesn't really matter, or current node. And the current node or current POS is going to be equal to the child node list in square brackets I, so the current item we are looping through. And since it's of type transform, we just need to add position because we want to have a vector instead of just a transform. Okay, cool. So now we know the start of that. The next one is we want to check if I is bigger than 0, so we don't underdo it or basically have a position where we can start from. In this particular case, if I is bigger than 0, so we are at least at item 1, we're gonna draw our line. And for that drawing line, we also need to know what's the next, or actually what's let's see, yeah, what is the previous child node in this particular case. So we're gonna catch that into another vector. So we're gonna name it maybe previous position, whatever, or previous node. And we're gonna add basically from the child node list. Of course, there needs to be an equal sign over here. So in that, we're gonna say square brackets, and then we take I and say -1. So this is going to be the previous position. That's why we need to check if I is bigger than 0, so at least 1. Otherwise, we would have an underflow over here, and we would end up within a minus or negative number when we are at the 0th position. And that would end up bad. Okay, so next one is, of course, we need to store the position of this particular item. So we say dot position. Since once again, child node is of type transform and we need to add position to this. Okay, cool. Now let's actually draw the gizmo. In this particular case, it's going to be gizmos.drawLine. You can also do anything else. You can also use handles if you like to. So we want to draw our line from our previous position to our current position. So basically those two, vectors, local vectors over here. So the first one and the second one over there. If you now save that and we go back to Unity, we should see a line between those two nodes or between those two fields over here. So as you can see, there's one green line. So whenever we are moving something around over here, this line is always going to stay in between that. So when I duplicate this one now and move this over here, you can see there's another line automatically added. And at the same time, since we're doing this, we also have all these nodes now into the child node list, as you can see, whenever you're opening this one over here. Okay, so, but how do we actually move on this field now? Let me pretty quickly create something like a 5x5 or 4x6. Actually, it doesn't really matter. You can also automate that stuff later on. I just go the simple way. Let's assume this is going to be our Monopoly or Ludo field, whatever. And we're going to have to walk from one point to the next. We want to make sure that all of these are going to be connected correctly. I have no idea if the amount is matching, but it seems so. So I'm gonna do something like that. You can also create several different board games, like a snail one, where, for example, you need to reach a specific goal, for example, and you need to make sure that you hit this field with your whatever stone. Okay. So once again, the board design is up to you. So you can actually talk about, or we can talk about stuff like that later on. If you have any question, of course, feel free to ask anything you'll like to. So, okay, so now we have our field instantiated or basically created, and we can once again design it in any case. Let me create a stone, which we can basically move from one point to another. So first off, I want to make sure that I create an empty game object, which is 0, 0, 0, or set this one to 0, 0, 0, because this is going to be inside our route or inside our stone over here. I can barely, fit this to wherever I want that to be. So what I can do is I can snap by holding down the V key. Probably I've seen the video about snapping, and I snap this one right over there at the top of this particular part over here, and then I snap this one back into the center with a control key just to make sure it is on the top of my playfield. Now what I want to do is I want to rename this, and I can name this one stone. So, or whatever you please. And what I want to do is I want to add a cylinder to this. And since the pivot point of the cylinder is going to be like in the center of the cylinder, that's why I created the stone directly over here. Now I can shrink down the cylinder to whatever I want. You can also put in your Helmer stones, whatever, into your game, of course. And now I want to lift that up so it is actually matching this ground plane over here. So basically gonna do the same. I believe there's one problem I made, which is going to be the stone over there. I guess this needs to be on the bottom, but the cylinder needs to be on the top, of course. And so I'm gonna snap this. So as you probably noticed, when I'm not doing this, then since I'm going to use the center point of this particular object, of course, this Helmer stone needs to be on the top of the surface, basically. So now I zero this one out on X and Z, but not on the Y axis, because once again, the stone is going to be inside over here and is moving like from one point to another. Cool, that's probably everything we need to do over here. And what we now need to do is, of course, we need some stone code. So in this case, I can go over here and take a stone or create a stone C# script and put this onto my stone, of course. I don't need to do anything else at the moment. Just take the stone script and put this onto it. Let's open this one up in Mono Developer Visual Studio. And by the way, if you want to learn more or want to have more, have more interest into complete games and so on and so forth, feel free to check out the description. There are going to be several courses I've created on Udemy with, several different content and several different game ideas and stuff like that. So let's go forward. This one has opened over here. So now we're gonna create everything we need to do about the stone. So for now, I'm gonna get rid of start and update. We're gonna make use of that stuff later on. So first, what I need to do is, or what my particular stone needs to know is a route position. So on what position are we actually starting? And we can actually, or literally, override this at any time. I'm gonna make it private since currently I don't see any point into making this one public for anything or for anyone, except later on probably whenever you want to, let's say, hit a stone with another one so you can basically check if there's some position or something there. Welcome, Bitch here. Thanks a lot for tuning in, man. Yeah, kind of busy these days, so I give my best, and I have so much projects at the moment running, so yeah. Let's continue. I want to have a public integer called steps, and this is going to be basically whenever you're doing steps, it's like you roll the dice, you have a number between 1 and 7, or 1 and 6 in this case. I'm going to explain this in a moment. And well, we're gonna feed in this particular steps and count this one down later on whenever we are doing one step. And meanwhile, we are counting down these steps to 0. We're gonna increase route position, of course, to move from one point to another. Rather simple, right? So another one I want to implement over here is a boolean called isMoving. This is actually making sure that we don't overdo it, and whenever we are already moving, that we are unable to do anything else, just as a protection. So let's get into what else? What can we do? Yeah, let's get into moving. First off, I recommend never ever, if not or if possible, avoid using the update loop, because update should be just for input but nothing else. So what I recommend is always, as much as I can, use coroutines, because these coroutines are basically doing everything next or like in an extra thread without touching update loop, which is running 60 times a second, and you don't want to do that, especially if there's more than just one job going to do over here. Yeah, thanks a lot, Bashir. I will try my best. Okay, so a coroutine is created or called also an enumerator. So if you're creating, instead of a void type, it's going to be an enumerator type. And I'm gonna name this one move. So what I want to do is, at first, I want to check if we are moving or not. And if we are already moving, like if the bool is moving, is already running, then I want to make sure that I break out of the enumerator and don't run it the second time. So this is important over here. So what we want to check, if is moving, so if that is going to be true, actually, then we just say yield break. So we break out of the enumerator and never touch it again, or basically wait until we get the next input. If we are going to be running outside of that, or actually whenever we are passing this one because we are not moving at this particular point. We want to make sure that we are setting is moving to be true. So we now know, okay, we are inside the full or inside the enumerator, and we are now actually able to protect this. At the very end, you want to make sure that you're gonna set is moving back to be false. But this is only happening, of course, whenever we are done with all of that stuff in between. And the in between is going to be rather simple, of course. At first, we create a while loop, and this while loop should check how many steps are left. So if steps is bigger than 0, we want to stay inside this particular while loop. Hi, Jesus. Thanks a lot for tuning in. And of course, thanks a lot for the nice words. And what we want to do is in this, we want to first check what is going to be the next position where we want to go to. So I'm going to catch this, of course, into a vector3. I'm going to name it maybe next position or something, next POS. And we set this one equal to, and now the fun part starts, which I have not over here, but we're going to implement this, is going to be we need to talk to the current route which this stone corresponds to. So what we want to do is we're going to create a public route. We have the route script already, right? So we're going to take this, this one, and we name this one current route like this. So we need to drag this later on into. We can also initialize that, automate that things, and so on and so forth. Doesn't really matter. So, but what we need to do is we need to have a connection to this so we can basically check what is the current route position. So we talk to the route position, of course, based on our current route position, so we can actually make sure that we are hitting the correct one or actually are able to do this. So, and to do all of that, of course, we're going to talk to it directly and request the list's route position and give it an extra step, like a +1 onto this. So how do we do this? Of course, we talk to current route. Then we want to access the child node list, so the one we just created beforehand. And that's why I put this one actually into the public, as you can see over here, so I can directly talk to this child node list and make use of it. So, and in square brackets, we're gonna put in the current route position, so the route position of this particular stone, and add, oh, it doesn't let me, and add a 1 to it. So the next position is not the current one, but the next one, like the current position +1. Yeah, thanks a lot. Once again, Jesus, I'm happy to hear that. So current route, and since we are once again catching a vector over here, we need to request the position of the actual part of it, like of the game object over there from the transform. And once again, do dot position as we already have done before, just to make sure we get the vector out of it. Okay, so this is going to be the next position where our stone wants to go to. Okay, cool. And since we have that, we now need to move to it. And since we are in a enumerator, we can also make sure that we combine this enumerator with a bool which is returning if we are still moving or not, or if we have reached a specific position. So what I will do is I will create a little bool function like here, and I call this maybe move to next, I don't know, node, whatever. And what we want to request is actually the next position vector. So in this case, I'm gonna name it maybe target or goal or whatever. It basically doesn't matter. So what we now need to pass in is from this, or actually we pass in the next position vector into this as a goal. And this bool should return if a step is actually left or not, or if there's something still moving or not. How do we do this is, at first, a bool always needs to return something, so we say return. Next is we want to take the goal and we want to return if goal is not equal. And now the fun part starts in open close parentheses. It's going to be a bit long. I still try to explain it as good as possible. So basically what we do is we move, let me put this over here. Give me a sec. So, okay, first off, if you move stuff, you move the transform the position usually, and you say it's equal to something. And that's equal to something like moving towards a point or whatever vector. So we're going to make use of vector3 dot move towards. Dot move towards this one. You probably know this already. You walk from one point to another point, and you can declare what is the current point, what's the target point, right? As you can also see in the description of that. So our current point is going to be our transformed position no matter where we are, and our goal position is of course going to be the goal. And the last one is going to be the speed times whatever, time to delta time. So I'm gonna take maybe a speed of 2. So 2f times time to delta time. This one. Okay, so and basically that's what we're gonna do, right? When we are moving from one point to another. But what we can also do is we can encapsulate or take this complete part and return directly the that one as a Boolean character, basically, or a Boolean, like is it a true or false? So what we do is we're gonna take this complete part over here, including the last parentheses. I'm gonna copy this or whatever, or cut it out, and put this into this parentheses set over there. And of course, at the very end, I'm gonna put a semicolon. So basically, I just copy and paste the complete part from this in between some parentheses over here. So what does it mean is now, if goal is not representing this, or actually has not been reached, then we return false, otherwise we return true, right? Since, once again, we return a Boolean. Where is it? Give me a sec. I just want to make sure no typos are appearing. Okay, looks good. So I hope you got that. And basically that's how we move from one point to the next. The simplest way. So, and since we are currently once again in this coroutine over here, we now need to wait until this one returns true. How do we do this? Of course, we're going to put it into a while loop. So while we are waiting for that particular movement, we return nothing and wait until this is done. That's what a coroutine usually is actually for. So what we need to do is while, and now we call the function move to next node, and we put in the next position we have calculated beforehand. And then after the second parentheses, you can also put this in the next line. Basically, it doesn't matter. Open, close curly braces, and we say yield return null. So we do wait until we are reaching this particular point. So if that is returning true, only then we're going to move to the next step inside our coroutine. So once again, thanks a lot for the nice words. I'm absolutely glad that you guys like what I'm doing over here. So let's go forward. Once we are done with waiting until we are reaching the next node, we want to, let's say, wait a small amount of time, like a dip, like 0.1 second or something between those turns. So it's looking a bit, let's say, more appealing. So we say yield return new, wait for seconds over here, and we're gonna put something like 0.1f in between. You don't have to do this, but actually it looks better, I guess. So, and as explained, we're gonna reduce steps by 1. So we can say steps minus minus, or minus equal 1, doesn't really matter. And we increase route position by 1. So we can say route position plus plus or plus equal 1. Once again, same deal, up to you. We just add 1 or decrease here 1 and add 1 here. So once again, when we are decreasing steps, we want to make sure, of course, that we are able to go outside the while loop and do not stay inside an infinite loop, basically. So this is going to be basically everything we're gonna need to do over here, I guess. Let's see. We, of course, reset is moving to be false whenever we are leaving the second while loop. So this one over here, oh, maybe I leave a space. And that's everything we need to do over the movement. Really, that's it. Okay, but since we cannot make use of it, like we don't have anything where we can set steps to something, we can, let's say, try to put in some kind of dice mechanic. It's a super simple one, I promise, nothing fancy at all. And as I explained before, you want to make sure that you use update only for inputs. So in this case, I'm gonna use my update loop over here just for one particular input. In this case, and to roll the dice for my one character, for my one small cylinder thing over there. So that's what I'm gonna do, and I'm gonna make use of my spacebar. So input. So if input dot what is it? Get key down. So I want to press this one just once. So I'm gonna make use of the key code dot nope key code dot space, wherever it is, this one. So if I press space, I want to do roll the dice. But I also want to make sure that I put an end operator here and make sure that we are not moving. So if it's not moving, this is going to avoid that we are rolling the dice and doing some fancy things, or trying to start the coroutine at least a second time. So basically we protect it here, but also we protect it over there, so we are unable to roll the dice whenever we are already or still moving. So this is just a second protection in this case. Cool. What we want to do is we want to roll the dice. So we talk to our steps. This is going to be this one for our dice directly. This is going to be the steps we are going to walk. So steps is equal to, and now I put a random dot range value over here. So we have a random range between 1, which is the smallest number on a dice, and then we're gonna put a comma, and then the maximum is going to be a 7. But wait, why is that going to be a 7? Usually 7 never gets rolled. The full or integers over here are always reduced by 1 at the maximum over there. That's why you need to put a 7 over here. So if you have a 10-sided dice, you need to put an 11 over there. Just keep that in mind. So what we can also do is, just to make sure, we're gonna debug that so we know what is the actual, what do we have rolled, and we can check this out meanwhile doing so. So we're gonna put this debug log, and maybe we're gonna put something like dice rolled a number, and we're gonna put this number plus steps. So steps is now the rolled number we're gonna have over there. Cool. But still, we should make before we actually start the coroutine, in this particular case, we want to make sure that we don't have any overflow. Overflow means whenever the list is ended, like the route has an end, that you don't want to overdo it. If you want to loop through the route, you can actually do this, but you need to make sure that you overroll it completely correct, which you can do in the route specifically later on. Like on Monopoly, you always go in the circle. It doesn't really matter how much rounds you're going to do. But in Ludo, for example, you don't do this. So I'm going to show you the Ludo way at first. So what we're going to do is we've talked to the route position over here. So we actually calculate the route position plus the currently actually rolled steps, like the dice, which is actually this. So for example, if our route has 10 fields and we are on route position, let's say 5, and we roll a 6, but we only have 10 fields, we would have an overflow of at least 1, meaning we are going out overboard, or basically we are unable to do this turn, and we would get a null reference or an argument out of range because the number we have rolled would overdo the size of the list. That's not what we want, and that's why we're gonna say we add the route position plus the steps, and we want to make sure that this is actually smaller than our current route. So once again, the route which is containing the list, and of course we need to call the list, the child node list, and we want to make sure that it is smaller than the complete amount of that. So child list or child node list dot count over here. So only if that is the case, we want to start the coroutine, open close parentheses, and of course we call move inside. You can do it this way, or you can use the string way. Basically here, it doesn't really matter. If that is not the case, we want to put a debug line into an else statement like here. So that means we are unable to roll the dice. So we say debug.log, open close parentheses, and we can say rolled number is too high, something like that, whatever. And you can also just go to the next step at this particular point, like over whatever, go to the next player, or just whatever it is. Let's get into moving. For coding, we are basically done with that. Let the compiler run and see if the console has any problems. If you're new to Unity, make sure that your console is always visible anywhere on your screen so you don't miss any argument out of range exceptions or anything else. Cool, so now we have our stone, and as you can see, we can now add our current route. And our current route is going to be this one. Once again, you can put in any route you like over there. You can design it as you please and like. And what we're going to do is in our stone, we're going to put this particular route. That's it. I'm going to make it, I don't know, green or blue, whatever. My little player part here, so we can see this one better. Gonna make a material, maybe a red one, or green, blue, purple, and gonna drag my red material onto my little cylinder. Okay. Once again, I'm gonna set it up a bit so that we see stuff better and we can keep on counting up correctly. So I'm gonna move the camera inside over here, take the camera, go to game object and align it with the view so you can see the game field is now aligned with that. A bit not too cool. Align with view again. Looks better. Okay, let's press play and see what's going on. So as you can see, we're gonna be here in our little dude is sitting on this particular spot, and we haven't changed the current position or the route position because we always start at 0. Well, usually, except you're gonna have a starting point over here, then you need to make sure that you count the correct position, like you have to count all the fields and negate the number by 1 so you know what's the current position of the route. When I now hit space, I move my fear or my little my little knob, my little character over here has moved to fields because, as you can see, well, rather badly, I guess, at the moment, in the console that I rolled a dice of 2. And what we can do now is we can now fiddle around with the speed and can do until we are reaching the very far end over there. I'm gonna deactivate the maximize on play right now so we can see stuff better. And of course, we can check out all the needed stuff over there. So we rolled a 3. So we walked from first point to the next, like 3 fields. 1, 2, 3. Cool. Let me go into my little guy over here where we are moving this, and instead of using a speed of 2, I probably use a speed of 8 to give it some little beef, I would say. You can do this as an open, public, whatever variable if you like to. And let's play again and see what's going on with that speed. So 1, 2, 3, 4, 5, 6. Pretty lucky one. As you can see, I never will roll a 7. I will always have between 1 and 3. And I can move my character now. And now as we are at the very far end over here, you can see the rolled number is too high. Now I can keep on putting the space bar until I have, as you can see, a 1. And he's only going 1 more forward. And from now on, all the rolled numbers will be too high because this is the very end over here. Once again, if you have a monopoly field, you just need to make sure that you are, whenever the next number is going to be too high, you're hopping to the 0 position over there, and then you start calling or ruling, whatever, actually going forward for that as well. I'm currently thinking about maybe just doing this one pretty quick so you have a little overview for this as well. Let me just reduce that some nodes over here. Maybe I'm gonna keep number 18 and drag this one over there. So this is like a monopoly field, and at the moment we're just going to be over there at this position. So whenever you want to go to the start field or over the start field once again, you need to make sure that you are able to move from this point to the next point. In this case, we need to tag that in here as well. So in this particular case, we need to get rid of this part because this is otherwise not working correctly because we are always checking if this list is going to be higher than that. But whenever we are moving over here, we need to make sure that this route position over here is actually able to be visited. In this case, we need to check what the current position or what the route position is and reset it accordingly. What do I mean by that? At first, let me all of that is going to become obsolete. Meanwhile, you're doing a monopoly field, which is like around, 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 around. So I'm gonna just start the coroutine over here like this. So we always move whatever, doesn't really matter. But once again, we need to make sure that this route position is going to do an overflow automatically. So I believe the best way is going to do the calculation before we are actually creating the next position node over there, or the next position. So let's see how can we do this the very best way. I believe it's just something like a 2 if statements. So basically, we're gonna maybe check this one at first. Let's see. Oops. Give me a second. Gonna copy some stuff around. So what we need to do is we want to avoid once again to overdo it. And so whenever this route position is going to be bigger, let me think about it. Actually, yeah, that's how we can do this. So if the route position +1 is bigger, I guess it should be bigger. If not, we're gonna change that. So if this route position +1, probably I'm gonna put this into some pair of parentheses just in case. So if the route position +1 is bigger than the actual amount of this particular route list over there, so current route.childNodeList.count, if that is the case, probably we want to make sure that the next field, like the next route position, is going to be the zeros position in this case. Yeah, hi Daniel. Yeah, that's a good way. Using a modulo is pretty decent. I guess that's what we can make use of as well. And I believe both ways work quite horrendously. But yeah, the modulo is going to be pretty decent, I guess. Let me take that, of course. So oh, okay, I'm gonna take yours. So I implement the route position before. Basically, I'm not quite sure if that is going to work if we are doing the implementation or the increment over here as well. But that's what we do here anyways. So I'm gonna try that. So route position plus plus, and of course route position modulo equals, so meaning we are not able to overdo the child count or the child list.count. That's what the modulo is going to be, and resets the route position automatically back to 0. And that's the thing which is Daniel is going to show us over there. I didn't thought about this point, so pretty decent. So what we're gonna take is once again the current node child node list.count over here. Oops. Sorry about my phone. And what we're gonna do is in this particular case, I believe we gonna take the route position and put this over here. So we increment this by 1 at first, like in the first step, and take the increased route position over here. But I guess we need to kill or destroy or delete this one over here. I don't know. Let's test it out. Because incrementing this one 2 times doesn't really make sense over here. So no problem with the code. And let's try that out. I'm gonna do some quick rolls over here. And let's see what's going on. Pretty good, Daniel. Thanks a lot for that. Hell, it works horrendously. So now you have a Monopoly style working, walk around, stuff like that. So whenever you're hitting the last field of the child node list, basically the modulo is going to reset the route position to be 0. Once again, it cannot overdo it and starts from scratch or starts from the beginning over here. Pretty decent. So now you know how to do it with a Ludo. Now you know also how to do it with an yeah, unlimited, playfield, stuff like that. So yeah, pretty decent. If you have any questions, feel free to ask pretty quick or just, yeah, leave it as is. And if you've missed the complete live stream, no worries about that. This video is going to be available after whatever time it takes from YouTube to make this one as a public video. So if you have any questions, feel free to ask. If you are having no questions at all, feel free to comment in the yeah, later on in the whatever comment section over there. If you have any yeah, anything you want to go and send over here. So once again, feel free to check out all my Udemy courses, which you can yeah, check out over there. Hi Profi, thanks a lot for tuning in, but certainly kind of late. So if you have a quick question, feel free to ask. And yeah, check out my videos if you like to. And that's pretty much everything I guess I have to cover over here about board game movement between all of these tiles. Since it was a request from somebody beforehand, so if you have like games like Mario Party, whatever, this is going to be probably going to become handy stuff over there. So, any questions left before I actually stop the stream? If yes, then please write them down right now. Otherwise, I'm gonna leave you guys alone and wish you a nice weekend, or yeah, the rest of the weekend, depending on the time zone wherever you are at the moment located. You're welcome, Bitir. No worries. No questions? Okay, cool. If you later on have questions, feel free to ask them once again into the comments below the video. Thanks a lot for tuning in and for your time. I hope you enjoyed this section. Thanks a lot, Daniel, once again for the little coding part over there. Yeah, that's nice, Daniel. Currently, I'm working on a Ludo way as well, like basically the same principle as we already have over there. So, and I was starting this one already beforehand. It's going to be, or it's currently a while ago, and I have messed mine up as well because of all the rules which are implemented into Ludo. So, yeah, since, like all of that. This game in Ludo, it's going to be like you have colored things over here, like these players, like up to four per corner. There are four people which are playing against each other, and then you need to make sure that you bring all your stones into your own, let's say, area. I would say. And yeah. Oh, by the way, there's one more small thing I want to implement or actually talk about is because of the fill nodes area over there, since again in the build, on-draw gizmos is not going to be inside. So the last thing I wanted to make sure that you're gonna add this is that you're gonna fill the nodes inside the start function. Just make sure you're gonna add this so you don't mess it up. So later on, when you're basically going to deactivate that completely, and um, that's what you want to avoid, actually. So make sure that you later on draw gizmos deactivate, or you cancel this one out completely as a complete on draw gizmos function. There is some coding thing like if I don't know, Unity editor something, something like that. Only then you want to do this. Otherwise, I guess there's an end if or something around here. So only if Unity editor. I'm not quite sure if that is correctly written over there, but something like that. And you want to make sure that this on raw gizmos function is only running in editor. Later on, is not going to be inside the build. Once again, it will not be implemented anyways, but you need to make sure that fill nodes is going to be in this start function. Once again, don't forget to save everything, and that should be it for now. Currently, Profi, I don't have any Ludo game at this, but check out YouTube. There are a bunch of videos about the Ludo games directly. I'm currently not creating this one, or I basically work on a course about Ludo games, like complete Ludo, whatever, with all the rules and all that stuff. But it's going to take some time until I am able to bring this one out, I guess. Since once again, there are so many rules you need to take care of, like when there's some stone onto one particular field, that the stone is able to throw it out into its main base and so on and so forth. But all of that rules are kind of messy and need to be implemented correctly, I guess. So actually, the playfield needs to know where is which person's stone, or is this stone basically able to go to one particular field, whatever, if or if there's a place for multiple ones. So all of that and even more is hopefully going to be in this course, but currently, I'm still working on it and try to finish it as soon as possible, I guess. But once again, I hope you enjoyed this live stream. I wish you a nice weekend. Enjoy your free time. And of course, keep on making games. And if you want to have some specific live support from me in the future, like just for your specific project, feel free to contact me over my website. And that's the way to contact me, and we can probably do some live sessions or whatever, and I can help you out with your particular games. Except horror games, forbid here. Okay, if I'm stuck somewhere else, could I ask you for some help? Of course, a bit here. You can do so. I don't like horror games in total, but if there's something on the coding side, feel free to contact me on xOctoMangames.com, which is once again the link is in the description below. And you can hire me basically for some help if you like to. So, once again, I hope you enjoyed this one, and feel free to contact me whenever you have some things you want to get finished or done. Okay, have a nice weekend. Thanks a lot for tuning in and enjoy your time. Bye bye.